So the big picture for this lesson is simplifying trig identities, and I chose this example from the lesson to explain it. Basically what you do is you simplify one side of the equation so it looks like the other side. And what you do is you start with the most complicated side first. So the most complicated side here is cotangent squared x plus 1 times sine squared x minus 1. So that's the side I'm going to start with. So I'm just going to write that down. Okay, then what I'm going to do is I'm going to try and simplify. So this is a Pythagorean identity. Cotangent squared x plus 1 equals cosecant squared x. So I'm just going to write cosecant squared x for that. And then the sine squared x minus 1, that's based off another Pythagorean identity, sine squared x plus cosine squared x equals 1. I need to manipulate this a little bit. I want it to be sine squared x minus 1. So what I'm going to do is subtract cosine squared x from both sides. So I'm going to get sine squared x equals 1 minus cosine squared x. And then, to make it look like what I'm looking for, I'm going to subtract 1 from both sides. So I get sine squared x minus 1 equals negative cosine squared x. So the sine squared x minus 1 becomes negative cosine squared. So we're multiplying those. So being able to find and apply the correct identity makes this a lot easier. If I didn't apply a Pythagorean identity, I could FOIL this and then maybe simplify it that way, but these identities make it a lot easier. So now I'm going to break it up into sines and cosines. Cosecant squared of x is 1 over sine squared x because of the reciprocal identity. So it's that, and then times negative cosine squared x. So I'm going to combine these together, equals negative of cosine squared x over sine squared x. So cosine divided by sine is cotangent, so this is equal to negative cotangent squared of x. Look what I have here. That's the same as this side here, so I've verified the identity. So that's what you do. You simplify one side as far as you can, and then you may have to simplify the other side a little bit too. But you cannot treat it like an equation because you haven't verified it is true yet. So you can't add, subtract, multiply, or divide by both sides of the identity because you haven't proved it yet. Once you've proved it, those equation steps are valid. But in the meantime, you can only simplify one side, simplify the other side. So that's the big picture.